Hi class, today we're going to learn about 5.2 medians and altitudes of triangles. So the first segment we're going to learn about is a median. A median is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. So in the picture, you can see that our median is going from vertex C to the midpoint of the opposite side. The midpoint is shown by marking both sides congruent of that midpoint. So in the picture, CD is a median of triangle ABC. Just like the segments we learned about last class, medians will have a point of concurrency. The medians of a triangle intersect at a point called the centroid. That is 2/3 the distance from each vertex to the midpoint of the opposite side. So what this means is that if you look at a median, for example, we could look at BL. BP would be 2/3 of the distance and PL would be 1/3 of the distance. So we're going to write that by saying that BP is equal to 2/3 of the whole distance, which is BL. And the same thing is true for the other medians. AP is equal to 2/3 of AK, and then CP is equal to 2/3 of CJ. The centroid is also the balancing point or center of gravity for a triangular region. That just means if you could balance this triangle on your finger, you would have to put your finger at the centroid. So let's try some examples. Find X if EG is a median of triangle DEF. Since it's a median, that means it's going from a vertex to the midpoint of the opposite side. So we're going to show that that's the midpoint by showing that 5x minus 17 is congruent to 3x plus 1. Now we can set those equal. Subtract 3x to get 2x minus 17 is equal to 1. Add 17 to get 2x is equal to 18. Then divide by 2 to get x is equal to 9. Example 2, in triangle ABC, Q is the centroid. BE is equal to 9. Find BQ and QE. Well, BQ is going to equal 2/3 of the whole, which is BE. We know that BE is 9, so that means BQ would equal 2/3 of 9. You could write that as 9/1, so this would be 18/3 when you multiply those fractions straight across, which gives you 6. To find QE, QE is going to equal 1/3 of the whole, which is BE. So QE would equal 1/3 of 9, which means that QE is equal to 3. So BQ is 6, QE is 3, 6 plus 3 equals 9. Example 3. In triangle JKL, PT is equal to 2. Find KP. So we were not given a vocabulary word in these directions, so we need to see what type of segments we have in our triangles. we can see we're going from a vertex to the midpoint of the opposite side. So this triangle is showing medians. The point where all the medians meet is called the centroid, so that means that P is the centroid. And we need to use that centroid property, which is that 2/3 property. So right now, PT is equal to 1/3 of the whole. The whole would be KT. So PT is equal to 2. That's 1/3 of KT. So you could multiply by 3 on both sides to get rid of that 1/3 to get KT by itself. So that's going to give you 6 is equal to KT. So now we know the whole thing is 6. That's what KT is. So that means KP would have to equal 4 in order for those two segments to add up to 6. So KP is equal to 4. Because we would do x plus 2 equals 6. So that x would have to equal 4. The next segment we're going to talk about is an altitude. An altitude is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. So basically an altitude will always go from a vertex and it will be perpendicular to the opposite side. Over here we have an obtuse triangle. So we're going from vertex B, but we can't draw an altitude inside the triangle because it wouldn't be perpendicular. So it's going to be perpendicular to this line containing the opposite side. In both cases, BD is an altitude from B to AC. Orthocenter is going to be the point of concurrency. The lines containing the altitudes of a triangle are concurrent. Intersecting at a point called the orthocenter. So this orthocenter doesn't have a special property. It's just simply where all of the altitudes are going to meet. Example 4. Find x and ij if hk is an altitude of triangle hij. So the way that we mark an altitude, it says that hk is an altitude, is we have to show that it's perpendicular to the opposite side. So that means that these will be right angles for it to be perpendicular to the opposite side. We can actually find x now because we know that 3x plus 3 has to be equal to 90. So 3x is equal to 87. Divide by 3 to get x is equal to 29. I know that ij is equal to ik plus kj. I can find out what both of those are by plugging in 29. 29 plus 8 is going to be 37, plus 29 minus 9 is going to give me 20. So ij is going to equal 57. So this is a chart that summarizes everything we've gone over last class and this class. The first column is going to tell you the names of the segments: perpendicular, bisector, angle, bisector, median, and altitude. The second column shows an example of each. The third column describes the word for the point of concurrency. The fourth column has the special property of that point of concurrency. And the last column shows an example of that point of concurrency. So make sure you keep this chart handy as you're completing these problems. For guided practice, we're going to practice first by identifying the segments in each of these pictures. So determine whether the line segment in each triangle is a median, altitude, angle bisector, and or a perpendicular bisector. So we can have more than one answer. So in the first one, this is not going to be a median because it's not going to the midpoint of the opposite side. It is an altitude because it's coming from an angle and it's perpendicular to the opposite side. It's not an angle bisector and it's not a perpendicular bisector. The next one, this segment is a median because it's going to the midpoint of the opposite side. This is also an altitude because it's going from an angle and it's perpendicular to the opposite side. This is an angle bisector because the angle is being bisected. And this is a perpendicular bisector because it's perpendicular to the side and it's also bisecting it. All right, the next one, this is not a median because it's not coming from the angle. This is not an altitude because it's not coming from the angle. This is not an angle bisector because that's not shown. So the only thing that this can be is a perpendicular bisector because it's perpendicular to that side that I circled and it bisects that side. Okay, next two examples. We're going to practice using our vocabulary words, median and altitude. So find AB if BD is a median, that means it's cutting this opposite side in half. It's going to the midpoint because it's a median. That means we can set those equal. So subtract x to get x on the right hand side, add 17 to get 20. Now to find AB, you're going to plug in 20 for x, so you'll get that AB is 13. An altitude goes from a vertex and is perpendicular to the opposite side. So these will be right angles, which means that 4x plus 10 has to equal 90. So 4x would equal 80 when you subtract 10, which means that x is equal to 20. It then asks for BC, this segment along the bottom. So we're going to plug in 20 to get 40 for BD, and we will get 56 for DC. So 40 plus 56 is going to give you BC, which means that BC is going to be 96. Okay, the last example. In triangle ACE, P is the centroid, so that means we're going to be using that 2/3 property. PF is 6. AD is going to be 15. Find each measure. So right now we're trying to find PC, which is the 2/3 piece. You should be able to tell whether something's 2/3 or 1/3 because the 2/3 piece will always look longer than the 1/3 piece where the 6 is at. So to go from 1/3 to 2/3, you just multiply by 2. So that means that PC has to be 12. Okay, to find AP, AP is right here. That's going to be the 2/3 piece. So we know it's 2/3 of the whole, and we know the whole is 15. So AP is going to equal 2/3 of that whole median, which is 15. So that's going to be 2/3 times 15 over 1, which gives you 30/3, and that will give you 10. You also could just use a calculator and use the fraction button to fraction 3 and times 15, and it would give you the answer of 10. Thank you, and that is all for the